So now we'll get started on the consumers and producers surplus. So these are the formulas that I explained a second ago in the last video. This page just summarizes all of the information that I expect you to know about these formulas. So I don't expect you to derive those formulas or really even explain them. I just need you to, again, be able to apply the formulas as we get to these problems. But remember that both of these formulas are essentially just an area computation. The consumer's surplus corresponds to this area up here above the equilibrium price, and the producer's surplus corresponds to this area down here below the equilibrium price. And both of these, notice, are integrals, both of these are integrals from 0 to x1. So both of these will require us to know the equilibrium quantity. That would be the x-coordinate down here. This is x1. So we might need to find the equilibrium quantity first before we can actually set up this integral. But let's look at an example here. So it says find the consumer's surplus at a price level of $150. For the price demand equation, d of x is given by 250 minus x squared. So in terms of a picture, here's what this would look like. We would have a demand that looks like this. So this is our demand. And the equilibrium price is down here at $150. And we're trying to compute this area. That area would be the consumer's surplus. So in these, we need to break into at least two steps here. Our first step is going to find that x1. So we need to find the equilibrium quantity. We know the equilibrium price right now is just $150. So notice that x1 is going to be the x-coordinate where these two curves intersect. So it's going to be the x-coordinate where P1 is equal to d of x. So in step 1, to find the equilibrium quantity, what we'll do is set P1 equal to d of x. That would give us 150 is equal to 250 minus x squared. And now solving this equation is going to tell us what the equilibrium quantity is. So that's important because remember, we're using this formula that says that the consumer's surplus is the integral from 0 to x1 of d of x, which is the demand, minus P1. So we're taking that demand curve minus the equilibrium price and integrating it. But in order to apply this formula, we need to know what this x1 is. So that's why this is our first step. Now, if I subtract 250 from both sides here, I would get that negative 100 is equal to negative x squared. And then multiplying both sides by minus 1, I'll get 100 is equal to x squared. And then if I take a square root on both sides, what I'll get is that x is equal to plus or minus 10. Now remember, in this case, we're interpreting x as being a total demand. So having negative 10 as our demand doesn't make any sense. So that means that x1 in this example has to be positive 10. So we've now found positive 10 to be our x1 value, or the equilibrium quantity value. And now we can compute our consumer surplus. So this would be the integral from 0 to 10 of d of x minus P1. And that will be the integral from 0 to 10 of d of x was 250 minus x squared, and then P1 was 150. So we're integrating that with respect to x. And I would recommend that before you actually evaluate the integral, you clean this up as much as you can. You clean up the integrand. So here we have a 250 minus a 150. So that will end up just being a 100 in total minus an x squared. And that'll make things a little bit easier to evaluate. So now we're just evaluating this integral. And we do this in the usual way. I just want the antiderivative of this inside thing, and then I'll evaluate at the integral bounds. So the antiderivative of 100 is 100x. The antiderivative of x squared is x cubed over 3. So this is our antiderivative, and we're evaluating this from 0 to 10. So if I plug in x equals 10, then I would get this expression. So this is just the evaluation at the upper endpoint. And then I need to subtract the evaluation at the lower endpoint. But notice that this is 100 times 0 minus 0 cubed over 3. So this is just going to be 0 altogether. And now if you plug this into your calculator, what you'll end up getting is $666.67. So in other words, this is the total amount of money that the consumers saved relative to what they would have been willing to spend if you could charge each of them the max that they'd be willing to spend. So if I could hunt around and talk to each consumer and say, what's the most you'd be willing to give me for this? And then they had to pay that maximum amount, then this is the total amount that they saved by instead paying the market price, which is $150. So this is not the savings of any one person. This is just the savings of the consumers in general by paying the market price relative to what some of them would have been willing to spend. Okay, so next let's look at another one like this. So we want the consumer surplus at a price level of $10 for this price demand equation. So let's go through the same sort of steps. So first, I just need to know what x1 is, because the consumer surplus is given by the integral from 0 to x1 of the demand minus the equilibrium price. And when I say the demand here, what I mean is the demand curve, not the value x. So we need to find the demand curve, and we also need to find the equilibrium price. We were told the price level already, so we know that P1 is going to equal 10. And we also know that the demand equation, or the price demand equation, satisfies this equality. So we can plug in the price level that we already know to find the value of x, and that will tell us our equilibrium price here. So we will plug in P equals 10 into the price demand equation. And when we do that, what we'll get is 50 times 10 plus x is equal to 900, but now the only variable in this equation is x. So that tells us 500 plus x is equal to 900, and therefore the equilibrium quantity is 400. So you can put a little 1 subscript there to remind us that this is the equilibrium quantity. So now we have x1, and we also have P1. That's just our equilibrium price, which is $10. The only thing that we're missing now is what is d of x. So that should be the price that these consumers are willing to pay to get a demand of x products. And to find that demand curve, what we need to do is solve for P. So this demand curve in general is going to equal the price at which you would buy x items. So to get d of x, you just solve for P in the price demand equation. That will always be true. So this value for P, if you just solve for it as a function of x, that will give you your demand curve. And we've done that previously in the class, but just to remind you that that's how we're going to find the demand curve. It's just by solving for P. So if I solve this for P, I would probably first subtract x from both sides so that I get 50p is equal to x, is equal to 900 minus x. And then I'll divide both sides by 50. So 900 divided by 50 would be 18 minus x divided by 50. So we would divide both terms in the numerator by 50. That would give us this. And that's our value for P. And therefore, the demand curve in this example is just going to be 18 minus x over 50. And now we have all the pieces that we need. So to compute the consumer surplus, I'm going to integrate from 0 to x1, the demand curve minus P1 dx. We found that the equilibrium quantity was 400 up here, so this is the integral from 0 to 400 of d of x is 18 minus x over 50. That was the thing that we got by solving for p in the price-demand equation. And then I subtract P1. P1 in this example is 10. That's the price that they're selling for. So this is the integral that we want to compute, and that will give us the consumer surplus. So again, I'd recommend that when you start computing the integral, you clean up the integrand a little bit. So here you have an 18 minus a 10, so that would just be an 8 altogether. So this is an 8 minus x over 50 dx. When I take an antiderivative, what I should get is 8x as the antiderivative for 8. And then minus, if I take the antiderivative of x over 50, I would add 1 to the power, so it would become an x squared, and I would divide by 2. So that would be divided by 2 times 50, if you'd like, or if you want, you can just put that denominator as a 100, because we're dividing not only by 50, but also by 2, because we promoted the power to a 2. So that's what we get. And now what we'll have is we need to evaluate from 0 to 400 in order to finish computing that definite integral. So if I plug in 400, I would get 8 times 400 minus a 400 squared over 100. And then I need to subtract the evaluation at 0. So this would be minus the evaluation at 0. Now, if you can just look at this and see that the evaluation at 0 is going to be 0, then that's totally fine. So notice if you plug in 0 into this, you'll just get 0. So you can leave this part off if it's clear to you that that evaluation is 0, but be a little bit careful because whenever you evaluate exponentials at 0, you normally don't get 0. But for these algebraic functions, usually you'll get 0 when you plug in. If you can't spot that right away, though, then just do what I did here. So just plug in 0 and then see what it ends up being later. But if I plug this entire thing into my calculator, then what I end up getting is 1600. So that's the total amount that these consumers saved relative to what they would have been willing to pay. All right. So in the next video, we'll do some examples involving the producer's surplus. The strategy is pretty much the same. The only difference here is that we'll be using a slightly different formula because remember that the consumer's surplus is defined by this formula where the demand curve is the top part. So notice the demand curve is the upper function here. Whenever we want to compute the producer's surplus, here the price is actually the larger function than the supply function. So there the formula looks slightly different. Here the price is the upper function and the supply function is the lower one. So if we want that area, we'll be taking the price minus the supply. And then when we integrate, we can find that blue shaded area.